Okay, good morning, everyone. I'm Marty Koistra. I work for the Housing Development Consortium. We have been planning for some time to have this experience. We were hoping, of course, that we could do this face-to-face, but as we all know, that is not likely to happen for a while. So because of the importance of this work, we wanted to keep things moving forward. You have some critical leaders who have been working hard as part of the Exemplary Building Task Force for some time to pull this together. Joe Giampetro, David Reddy, and of course Mark Deutsch and Lauren Tierney are here to help us today get through this. I'm going to be doing a few introductory slides. We ask that you mute yourself during the presentation, if at all possible. Of course, if at any time that you want to ask a question, there's a chat feature. I think all of you by now are probably somewhat familiar with Zoom. Lauren and Mark will be monitoring the chat as we go. And there will be opportunities for breaks, more discussion, breakout rooms, and all of that happening as we proceed. We're going to take some time to allow participants to quickly introduce themselves after I go through a few basic slides just to get us all on the same page today in terms of why we're doing what we're doing here. So at that point in time, Lauren will call you out as she sees your names on the screen and give you a chance to say who you are. But before we do that, I'm going to walk us through a few slides here about what the Exemplary Building Program is and why we're doing what we're doing here today. So please bear with me as we move through this. And by the way, all of these slides will be available to you at the Exemplary Building website should you require anything that comes out of today's discussion. So, with that behind us, thank you all for joining us today. I know that there are a lot of things that are distracting us today, things that are important, things that are critical in our day-to-day lives, in our society, and I know we're all a bit distracted and quite concerned. It's a challenge for us all to be present, and we really appreciate everyone being here with us. We also want to acknowledge the Edwards Mother Earth Foundation for their support of the Exemplary Building Program and helping make sure that we can accomplish what we need to today. So we will go through the kind of introductory stuff and get into the current context around 9 o'clock or so. Then we have subject matter expert panel that's going to dive deep into our topic of balanced ventilation and heat recovery. And we'll do some small group breakouts and a group report out. And if you can stay with us past 11:30, we'll be doing summary and conclusions and wrapping up around noon today. I know some of you may have planned to leave at 11:30. We understand that as well. So really, what are we trying to accomplish here? We want to produce a set of objectives, standards, and practices for including balanced ventilation and heat recovery in multifamily buildings. We want to gain clarity on what's required and how to achieve the requirements in the new code and what the current state-of-the-art solutions are today. We want to get guidance on how to proceed to implement early in the integrative design process. And we want to refine our Exemplary Building Program recommended specifications. So just to summarize that, the work that's been done by a number of subject matter experts under the guidance of Joe and David is here to help inform conversations, but we're not coming in today saying what the answers are to these key questions. We want to explore that with all of you. And out of this process, we will come out with a set of recommendations and guidelines like we did with the wall assembly. If we have time later today, we can point to the wall assembly guidelines, but all of you should have been able to see them by now on the Exemplary Building website. So let me just give us a sense of what's going on and why we're doing this work, just to make sure we're all on the same page. I think all know that we have an affordable housing crisis. We know that we have a climate crisis. We also know that we have a COVID crisis, which stems from a climate crisis. And we now also are experiencing the impacts of years and years of institutional and structural racism that are bound up and embedded also with our climate crisis and our affordable housing crisis. So we cannot disregard this moment in time. And I don't know who said this a while back, but you know, essentially climate change reality becomes more apparent. Technologies and methodologies improve. The ability to mainstream these practices at scale are hampered by the storm of high costs. We continue to be up against this every time we turn around. The tight labor market, which we hope will emerge even stronger coming out of this crisis. We lost 30% of our construction workforce in the last recession. We certainly hope that doesn't happen again. And I'll venture out there that our current delivery system may have just a small lack of imagination in how we get past these challenges. So we need ambition, we need scale. Why? Well, pre-COVID, here's some staggering information for you. You probably all know this, but if you look at what's been happening in terms of growth, our housing supply has not nearly kept up with the population growth. And this also has led to rents, which have grown much faster than incomes in King County. And, you know, it should be no surprise that these are clearly indicators of the problems that we face. This one to me is probably the most disturbing and the one that people really don't seem to get in the general population. But because of those rent increases, we've had a net loss of 112,000 housing units. They didn't go off the grid and fall down, were demolished or burned. They just moved way up in the rent spectrum. And so if you look at what's happening with this 30 to 50% AMI band of housing, take a look at where we're going to be in 2022, 2025 in terms of having any of that naturally occurring in our climate here in King County. So there's a tremendous amount of work that needs to be done to produce housing at scale. We know that there's tremendous pressures though also on the development community, delivering more and more units while controlling costs. We have to preserve our quality so our asset and property managers can actually maintain these things. And we have this climate crisis, which is something that we cannot disregard. So we believe somewhere in the nexus of these three ecosystems are the ultra efficient buildings that we could be building. We also know that our codes are continuously evolving, and Washington state codes for the building sector are evolving. I know there's been lots of pressure even this last legislative session to put the brakes, so to speak, on advancing code requirements. This is, again, one of those delicate tensions. When you go back to the previous screen, those of us who are advocating for more and more housing do not want to see imposition of more regulation and more cost. At the same time, though, we're all going to have to figure out how we compromise and work through those tensions. And the code is the driver that's going to help motivate us to get there. So I assume by now all of you know this, but by 2031, we have to achieve a 70% reduction in annual net energy consumption in the built environment. And so we're hoping at HDC that rather than wait till the 11th hour and wake up and say, oh, by the way, we have to change how we're producing our buildings, that we can take this period of time between now and then to quote unquote ramp up, to get our skill sets in place, to get our labor force adapted to the new methodologies, and really become awake and alert to how we can achieve this far before it stares us in the face. So when we talk about ultra efficient buildings, what are we actually talking about at HDC? We believe one approach responds to each of these urgent challenges and legislative mandates, and that is to produce these ultra efficient buildings. First, we think through state-of-the-art building design strategies and efficiency measures, we can actually reduce energy and water consumption and stormwater runoff. Then through adding on-site renewable energy generation and water capture. An ultra-efficient housing building maximizes the housing units produced, offers long-term life cycle cost benefits, and provides an improved quality of life to its residents. And I want to point out that last bullet point. One of the things that we are extremely concerned about as we consider the disproportionality of people of color and others who are facing housing insecurity in King County and in our country. We also have health disparities. I will just remind everyone that within King County, there are zip codes whereby people's life expectancy differs by 10 years. You can go down to Pierce County and that change in life expectancy between the highest and lowest zip codes emerges at 12 years. And so housing, as we all know, plays a key role in the health of the residents who live there. So we think that we need market transformation, and we think that the affordable housing community can help become leaders in this. I have heard a lot of resistance from the affordable sector saying, why can't the market rate people lead on this and we will follow? I really am not going to spend a lot of time honoring that conversation. I'm going to leave it up to each of you to figure out in your own hearts and minds why we believe that the affordable housing community can and should be leaders in this way. So the Exemplary Building Program has really taken shape under the leadership of Steve Gelb and the Exemplary Building Task Force. If you don't know who's on the task force, I would encourage you to go to the Exemplary Building website and look at all these wonderful volunteers who've been dedicating years now of their professional lives and their competencies and skills to helping us get to where we are in this process. So can we do it? Both affordable and ultra efficient? Yes, but process is the key. So we're using a community-based collective process of testing, learning, and sharing while exploring innovative strategies, including offsite construction. We have an offsite task force, and we are in a contest with Wells Fargo and Enterprise out of 800 and some applicants for that contest. We were chosen in one of 3 categories to be one of 15 applicants moving forward. So we'll find out at the end of this month if we move forward to the 3rd phase of that application process. But all in all, we think that working together with the innovative leaders that we have in our community, we can come through this. And that's one of the reasons why we have these charrettes. It's not to say all of a sudden we all know what needs to happen. We think that we have to work through how to make that happen with the dialogue and conversation and hard work that we're doing in experiences like the one we're having today. Environmental preservation, healthy homes, durable buildings, and balancing first costs without minimizing overall units produced. We actually believe this can be done, and we're going to continue to work hard through these pilot projects and demonstration projects to prove that concept with your help. I'm going to wrap up here with 6 high levels of success, or what I call our theory of change. The first is what we're trying to do today: develop and define standardized building practices and specifications, support early integrative design, and create consistency. We believe this will transcend the challenges arising from each nonprofit developed affordable housing project being a one-off design built completely by a newly assembled development team. I know we have challenges with how the public funding system works and all of these things that drive us towards this process that we currently use, which assembles new teams and has every project being one-off. I know that there are architects and others whose livelihood depends on the fact that we do a lot of design. We're not saying that we're trying to shut out the ability to be creative within the confines, but if you go back to the earlier slides showing what we're up against, I think it's safe to say that being 156,000 units short in 2017 means that there's enough work for everyone. And we think that standardizing practices and specifications can really help us become even more effective. It will also help us then in point 2, garner volume purchasing opportunities and discounted supplier agreements for essential materials. And we think this can help reduce the premium. And so we're in conversations with BPI and Alpin Windows. We're in conversations with Tyvek, with Aero Barrier, with a number of different groups right now, trying to figure out, can we come up with some supplier agreements that help reduce first costs. 3, all of this can lead us towards being able to deliver training and certification programs, and also expand a diverse contractor workforce. So tied to our work with Emerald Cities Collaborative, launching the E-Contractor Academy, we are working hard to diversify the subcontractor pool to make sure that there are people who own businesses representing people of color and changing the dynamics of our economic system, and garnering more and more people into the arena to help us with our workforce shortage. 4, finding sources of funding. So Seattle City Light has tremendously stepped up for these first 4 demonstration projects to help us offset some of that premium costs. Of course, the UHE program at the state and others as well. And then providing tools for owner-operators to make sure they can maintain the buildings, as well as help support and modify resident behavior. We think that end-user behavior is a big part of how we leverage ultra-efficient buildings, something that we all need to work on. And then finally, do this in an open source way, using word from IT or language from IT, essentially saying that we want to be transparent with what we're learning and bring all of this learning back into future projects so that we can consistently and persistently improve what we're doing. So that is, in a nutshell, what HDC is trying to do through the Exemplary Building Program. And I'm going to turn it over now to Lauren, and David's going to get his screen ready to go. But Lauren's going to help us walk through some quick introductions, and we'll go from there.
Thanks, Marty. To expedite this process, I'm going to go down my participant list and call your name. And when I call your name, if you could introduce yourself with your name, maybe title and organization as well, and any comments that you'd like to make, brief comments you'd like to make, that is optional. All right, so I'm gonna try to expand my list here. Maybe I can't. Okay, Let's start with Phoebe.
Good morning. My name is Phoebe Warren. I'm an energy analyst at Seattle City Light, and I am delighted to be here today. Seattle City Light is feeling privileged to be allowed to participate in the Exemplary building program and support it with financing. Thank you.
Thanks, Phoebe. Steve.
Steve Gelb, Director of Emerald City, Seattle, and volunteering with the Exemplary Building Program.
Alan.
Alan Dotterman, housing developer with Imagine Housing.
Amit.
Hi, I'm Ed Singh at Puget Sound Energy. I'm the program manager for residential new construction. Very supportive of Exemplary Building Program's mission. Still trying to figure out where exactly PSE fits in to being able to support Exemplary Building.
Great, thanks. Bill Singer.
State-funded UHE ultra high efficiency projects. It was completed last year in Everett.
Thanks, Bill. I think we missed the very beginning of your introduction.
Bill Singer from Environmental Works, architect. And I was just talking about the work we did on the Project Claire's Place, the state-funded UHE project that was completed last year in Everett.
Great, thank you. Brad.
Hi, Brad Carmichael. I'm an enclosure consultant with JRS Engineering and a volunteer with the EBTF.
Thanks, Brad. Charlie.
Charlie Rogers with the City of Seattle Office of Housing Weatherization Program. I'm a multifamily energy auditor and am interested in energy recovery mostly in the context of existing buildings. So I'm kind of interested on how the new code will apply in subalt situations.
And Mike. Stefan.
Mike Steffen. I'm with Walsh Construction Company. And I'm happy to be here.
Thanks, Mike. Eric. Eric, you may be muted.
Eric Vandermeer with Rushing, just a mechanical designer in Seattle, and also I've been in the code development process, developing as I work on the Washington State Building Code Council.
Thanks, Eric. Galen.
I'm Galen Stengel with Stengel Engineering. We're MEP consulting engineers, have extensive experience with high efficiency multifamily across the country. And I'm also on the technical committee for the Passive House Institute US. I'm glad to be here.
Thanks. Gladys.
Hi, I'm Gladys Leo Young. I'm I'm an architect with SKL Architects. Yeah, glad to be here too. Thanks for the invite.
Thanks, Gladys. And then I have a maybe a Doyle G or a Doyleg.
Yeah, it's Doyle Gustafson. I'm with Marpac Construction. I'm pre-construction manager, and just wanted to say thank you for putting this on. This is going to be very informative.
Great. Jesse.
Hi, I'm Jessie. I'm with Puget Sound Energy. I work with Amit on multifamily new construction incentives. Glad to be here.
Great. John Hall.
John Hall, architect with GGLO, leader of our affordable housing group and our carbon initiative. Thanks for putting this on today.
And Jonathan Heller.
Hi, Jonathan Heller from Ecotope. I'm a mechanical engineer, done a lot of work on multifamily. I think I'm excited to be here because this is an example of taking buildings to the place where they need to be 20 years in the future, but starting to do it now and starting to focus on this important building type. So great work.
Great. Casey.
Hi, everybody. I'm Casey Ledke. I'm a housing developer for Bellwether Housing. I'm also a volunteer for the EB program, and a member of the ESDS Green Team for the Washington State Commerce. Happy to be here. Looking forward to getting a high efficiency building built with Bellwether Housing.
Great. Kira.
Hi, I'm Kira Connery from Third Place Design Cooperative, an associate there, and I'm happy to be here.
And Lori.
Hi, I'm Lori Stellick with Seattle Housing Authority. I'm a project coordinator for the Yesler Terrace vertical construction, and happy to be here and happy to learn from some of these experts.
Great. Marcus. Marcus, you may be muted. All right, we will come back to Marcus. Michael Murrah.
Hi, I'm Michael Murrah. I'm with Seattle Chinatown International District Preservation and Development Authority. We're the developers and the owners of the North Lot project, which is participating as one of the 4 exemplary building programs.
Michelle Wang.
Hi, I'm Michelle Wang with the Renberg Architecture Group. I'm the principal in charge for affordable housing, and we're fortunate to be working with Joe, Gianpietro, and David on DESC's Exemplary Building Project, a PSH project in Rainier.
Okay. And Michelle Amadhai. Maybe muted.
Sorry. Hi, Michelle Amadhai, Catholic Housing Services developer there. And I was the developer who kind of jumped in right before construction, before Claire's Place, the property in Everett, that's a UHE building.
Right. And Mitsu?
Yes, this is Mitsu Koshima with Wood Harbinger, MEP Consulting Engineers. And I'm working on several housing projects with the Third Place, and interested to know more about balancing ventilation and energy recovery challenges, pros and cons. Thank you.
Great. Olivia?
Yes, this is Olivia with Marpac Construction. I'm an estimator. Glad to be here. Thank you.
Great. Rumi?
Hi, I'm Rumi Takahashi, Associate Principal at SMR Architects, looking into the exemplary building program for one of my clients, and also sort of standing in for Kate Smith at SMR, who's an HCC board member.
Great. Ryan Mino.
Good morning. I want to thank everybody for your time here to continue this process we've been involved with. I work for the Raffin Company, the general contractor.
Great. Ryan Merritt.
I'm Ryan Mertis. I work as an MEP coordinator for Walsh Construction.
Great. And Sai.
Good morning. My name is Sai Cholenpin. I'm one of the principal at Marpac Construction.
And I look forward to learning all this new information today. Thank you.
Sean?
I think you said Sean. This is Sean.
Yes.
Okay, sorry. Hi, good morning. Sean Oram with Ectope, supporting the HTC's push here and also participating in the EB pilot. So looking forward to this wonderful presentation. Thank you.
Great. Sloan?
Hello, Sloan Ritchie. Good morning. Cascade Built. We're a general contractor and infill developer in Seattle. I've been working on this this problem for a few years, so excited to be here with you all discussing the best solutions.
Great. James? Sarah James L. All right, James, we'll come back to you. Scott Crosby. You there, Scott? All right, we have Tom Eames. No, Tom. How about Mark Deutsch?
Hi, I'm Mark Deutsch. I am helping out with my project manager expertise as a volunteer for EBTF and HDC generally.
Great. Kevin, who just joined us, we're doing introductions.
Kevin Rao, project manager of the Raffin Company. Just interested in finding out what the next step is for construction.
Great. I'm going to let David and Joe introduce themselves in just a minute, but I want to make sure that I got everyone. We have a couple of just phone numbers that may not be associated with the name that I called. Anyone I'm missing or anyone that had been muted that wants to introduce themselves?
Yeah, this is Marcus Pereira-Kolb, like Bill Singer, also from Environmental Works, and a Passive House consultant. So shout out to Phoebe Warren, who was instrumental in getting Passive House off the ground here in Seattle, and Joe Giampietro, who's been doing great work for years as well. Thanks everybody for being here.
Great. Anyone else? All right, let's, how about Joe, you want to introduce yourself, and then we'll hand it over to David, who can introduce himself and start in with the program standards and specs.
Yes, great that everyone has assembled today under these circumstances that we have. And I think we're excited to be able to talk about both the program as a whole, but specifically balanced ventilation. I am an architect, passive house consultant, learned about high performance buildings and what's really possible about 10 years ago, and have been working with clients and developers, architects to help advance that since then. So with that, I'll hand it to David for an introduction.
Yeah, good morning. I'm David Reddy, building performance analyst and principal with the Brian 360, and also on the Exemplary Building Task Force. Yeah, thank you for being with us. And Joe, why don't you get us kicked off on just an overview of the program and specs?
Yes, so just to give you a brief background on the general picture of the program before we dive into the balanced ventilation component. Obviously, high performance building has been evolving over many years with many different players, And we've assembled a group here who have a lot of different perspectives, but we've been working hard for the first time to really pull together a set of standards that we think are applicable to going the distance to meet the 2031 state building code. So things are not entirely new, but there's new and different things we're asking people to look at. It's been arrived at through practical experience. It's improving and will improve over time. So everyone's feedback in this process is key. The task force has worked extensively to try to fine-tune the standards for clarity, cost effectiveness, and applicability. So there's 3 areas we like to focus on. One is the overall standards and what the pieces and parts of that are. I think a key one that is new for people to think about is going all electric, where there's no fossil fuels in the building, which pushes us toward how we provide domestic hot water through an electric heat pump system, which turns out to be a great new solution. Looking at conservation first in a building really focuses on the building envelope. And so we have some standards for that help get us to the goals. There's 2 aspects to the mechanical systems and electrical systems, which are the balanced ventilation with heat recovery and the heat pump hot water. Those 2 are sort of the new kids on the block, so to speak, that we really need to focus attention on because they're not inexpensive and they generate results over time. And so those are 2 key things that we're trying to work out through workshops. This one today on balanced ventilation, and one to come in the near future on heat pump for domestic hot water. The last 4 on this list are things I think everyone is more familiar with through the ESDS process, but we continue to learn how to make them better and improve over time. So looking at the big picture with whole building approach, the bottom line is our target from an energy point of view to get to 20 EUI or less, which is essentially 50% less energy than the 2015 Washington State Energy Code baseline. It happens to work out pretty much the same as the FIAS 2018 standard, which is Passive House Standard for buildings here in the US. And so it's a collective target that all of the various exemplary program standards are targeted at. And the way to get there most cost effectively is to look at these pieces that you see above that for integrated design from the beginning, looking at whole building modeling, focusing attention on the ratio of the amount of enclosure volume to floor area so you're cost effective, using advanced framing wherever possible to reduce cost in thermal bridging, making the floor plans efficient in terms of layout, and reducing window to wall ratio to where it's most effective, because windows obviously lose and gain more heat than the general wall assemblies. And then moving on to the next slide, in the enclosure standard, which we've previously published, we have some specific guidelines that are recommendations. They're not necessarily hard and fast, but we think by looking to this, it'll enable you to get to the overall building performance goal. So we won't focus on that for the moment, but we'll start looking here more specifically at the 2 MEP standards of balanced ventilation and electric heat pump hot water going forward. And so today, this new element of balanced ventilation with heat recovery is what we'll focus attention on, because it's something that's challenging and new and is, by the way, coming up under code, as you all know, later this year, assuming everything progresses as expected. So a couple of comments, I think, on the balanced ventilation program really is, why is that such a big deal? Why is it a key performance factor? How have we been getting fresh air up to this point in buildings? And clearly, fresh air becomes more and more important when we start talking about health and protection from virus. And so really, we've been doing it through leakage, trickle vents, but how does this change with better building envelopes? And given a choice, what is the best way to provide fresh air? So with that, I'm going to hand it off to David to start walking us through sort of the background of energy in our current Northwest code cycles and what's happening, and to lead us into the specifics of how to address it. So David, I'll hand it off to you.
Great, thank you, Joe. So I'm gonna dig into a series, the information we gathered to facilitate this workshop to just kind of inform the conversation. It's intended to address current codes, what people are doing in the buildings now when it comes to balanced ventilation, heat recovery, and some of the initial lessons learned, but we really do look forward to gathering more information from you all as we move forward here. So to revisit the targets we're talking about, I think a lot of people have seen this chart before, although maybe not since the 2018 code estimates have been updated. But we're on this trajectory to try and reduce the energy use in new buildings by 70%. And Seattle has a goal of being carbon neutral by 2050. So we all know that Seattle is even moving towards more aggressive goals faster. And as everybody knows at this point, the 2018 code has been moved to be effective in November 1st. So we've all gained a little bit more time to try and figure out how to meet the new code, and particularly trying to figure out balanced ventilation with heat recovery. So this chart, hopefully everybody understands, is in the context of a weighting of all buildings. The intent is that it's a weighting of all buildings in Washington State. And so if we just focus on multifamily, for example, we can kind of put it in the context of EUI, our energy use index, the amount of energy used per square foot of the conditioned building area. And what we have is we started, in a 40 to 45 EUI building. And, keep in mind, these breakdowns can shift around a lot depending on a lot of different design factors. But, there's a fair amount of benchmark data that suggests the average building built in 2006 is somewhere in that 40 to 50 EUI range. 2018, we've made some real strides towards that, but to get to 70% of our energy use in 2006, we're looking at having to achieve a building that's actually below 20 EUI. But it's not necessarily a foregone conclusion that the multifamily sector alone will have to achieve its 70%. It's all across all buildings, but we all know we have very good opportunities to reduce energy use. There's a fair amount of things that we can do, and we do have to carry our weight in this sector. So the 2018 codes, particularly the energy code, as I think we all know at this point, is driving this new requirement for balanced ventilation with heat recovery. There are a number of other changes in the 2018 code. I've tried to list a few here, but really this is, in my opinion, the big ticket item. And so that's why we're focusing on it today. Joe talked about, kind of raise some questions that we want to keep in mind. These particular slides are going to talk about why it's necessary, the code requirements, how do we integrate these into buildings, and trade-offs, and ultimately, we hope that this workshop will help inform an update to the exemplary building recommendations and specifications and the guidelines that we will publish. That's the real outcome that we're aiming for. So let's put all of this conversation in context. I think most of us here have worked across all sorts of different buildings, but what we're talking about today is primarily in the context of mid-rise multifamily. It's affordable housing, which could be workforce, senior, permanent supportive housing. So a lot of different occupant types and densities and systems. So, and primarily, at least currently, it's in the context of using electric resistant heat without active cooling built into the building design. And you know, where this conversation is really assuming we're building for 2018. We're not talking about what changes do we need to make to our 2015 buildings. It's how to move forward in 2018. So we've tried to distill the pluses and minuses of balanced ventilation and a lot of different aspects of what we're going to talk about today. You know, first and foremost, in my opinion, balanced ventilation is a principal way of improving indoor air quality. We know that exhaust air ventilation is not necessarily effective at bringing in fresh air. A lot of times you're breathing your neighbor's air and it's certainly not filtered. We know that by pulling air through the building envelope, that can increase the risk of failures. And if designed correctly, especially using electric resistant heat, it will reduce energy consumption. That's not, you know, I think that's not the primary benefit here, but energy savings is one. And certainly if we want to make buildings tighter, we can't do that without going to balanced ventilation. We all know a lot of the minuses: more cost, takes more effort to design, can take up floor space, and it can use more energy if it's not designed properly. So the relevant codes that are driving this are listed here. You know, it's a combination of mechanical code and energy code that we're going to talk about today that really define these requirements. We're going to talk about some of the aspects of the code, particularly what distributed ventilation means, and then talk about technologies for energy recovery. So what is balanced ventilation? The code defines it. It's that the airflow is mechanically provided using supply and exhaust fans that have airflow to the units within 10% or 5 CFM. You don't have to account for intermittent exhaust sources in that calculation of the balance. And there is flexibility in the code to have what's called the distributed or not distributed whole house balanced ventilation system. We'll talk about that. And it must operate continuously and, or at least generally it must operate continuously and be separate from the space heating and cooling system. What are the flow rates that are required? And there's two ways to determine that in the code. One is a table that you look up by the number of bedrooms and area. And there's also an equation that people can use to calculate it. They're more or less the same. There's a few building unit types and areas where you could justify a lower flow rate using the equation versus the table, but for the most part, they're fundamentally the same. One thing to note is that the rates are 25 to 30% lower than what's required in the 2015 code, just for the whole house ventilation component. So in my opinion, and maybe people that worked on developing the code can maybe comment on that later, is that it's principally because of we are pulling more exhaust fan flow just to compensate for the fact that it's not a very effective means of ventilation. So with going to balance, we can bring those flows back down. Distributed versus not distributed. So this was something actually I went back and forth with some of the subject matter experts, and I had to read this 3 times to try and get my head around what does this actually mean. And there's actually will be tomorrow at the State Building Code Council a discussion of a formal interpretation of some questions in this area. So, but as we've interpreted it, distributed ventilation means that you're supplying ventilation to each habitable space of the dwelling unit, bedrooms, living rooms, and you are also exhausting air from all kitchens and bathrooms. So if you don't meet that requirement, what the code says is that you have to increase your whole house ventilation flow by 25%. But really this means 30% more oftentimes once you round up to the nearest 5 CFM, which most all designers will do. So it's even though these flows are small, when you look at it on a building-wide basis, 30% more air does add up and can increase costs, duct sizes, operational, energy use. So it's something to pay attention to. So what does distributed versus not distributed look like? This is kind of a mock-up of one way of how I interpret it, and it's fundamentally coming down to whether or not you exhaust. So keep in mind that we still have to supply air to the bedrooms and living rooms, each habitable space, and but then exhausting the bathroom and the kitchen, having local continuous exhaust to the bathroom and kitchen. So it's really just about this exhaust grill and duct to the kitchen that is the difference. So in our opinion, we should include that and use the design for the lower airflow rates, or at least have the flexibility to design to the lower airflow rate. This diagram does also illustrate one thing in the code that everybody I think is aware of, is that you have to keep the separation between the intake for these ventilation systems and the exhaust separate by more than 10 feet. There are also operable window separation requirements that need to be paid attention to on the exhaust side. So there's going to be, especially if you're running this air through the facade, there's going to be a lot of, it's going to be busy, and it's going to be a challenge to kind of find where we're going to intake and exhaust this air. And then, coupled with the balanced ventilation, so that balanced ventilation is in the context of the whole house exhaust ventilation. So the ventilation done to consistently air change and remove pollutants. Local kitchen exhaust is a component of the overall ventilation scheme for a dwelling unit, and it's and it is or is not integrated into the ERV, or the balanced ventilation system. ESDS does require the range hoods to be exhausted to the exterior. The code allows use of ductless hoods, and there have been waivers granted by Commerce particularly for the passive house UHE projects with small apartments to use ductless hoods. But if the ductless hood is used and you integrate the kitchen exhaust, what we recommend, or what we're thinking at this point, is that the kitchen exhaust grill needs to be located at least 8 feet from the cooktop, and it does drive up the airflow rates. You get to accomplish that. And then you have grease filters in the exhaust grill and charcoal filters in the ductless grill that need to be maintained. So there's definitely some considerations there for integrating into that balanced ventilation system. To talk about heat exchanger types, so we will get into this, and ultimately we may make a recommendation, but just to kind of get everybody familiar, this is how we've broken them down. There's the plate type, which don't have moving parts, and you're just exchanging energy through what's called a core, oftentimes, or a series of plates that are sandwiched together. A wheel type heat exchanger basically is airflows do not mix, but rather this wheel rotates between them. In both of those, the airflows are not intended to mix. it's just passage of energy, but the wheel rotates through the airstreams and absorbs energy and dissipates it depending on what side of the airstream it's in. And then there are these what we've called unitized or ductless systems, which are intended to be not necessarily serve more than one room, and use different strategies than wheels or plates, maybe cycling of air back and forth through a heat exchanger rather than having two airstreams. But for the most part, we're going to be focusing today on plate and wheel technology, although the unitized ductless, there's products coming online and they could be useful for some applications. So, what are the heat exchanger types? So basically it can be broken down into two principal types: heat recovery ventilation, or HRV is a heat recovery ventilator, and energy recovery ventilator. Heat and energy, well, heat is energy, so it's a little bit confusing, but in general, an HRV is one that covers sensible energy only, and an ERV recovers sensible and latent. The latent part, sensible changes the temperature of the air. The latent part is related to the moisture, the water vapor, how much energy, how much of the water vapor can be transferred. And really, these differences come down primarily to how they perform in the winter when it's cold out. An ERV can increase the relative humidity of the ventilation air, whereas an HRV can't. Well, it's a little bit more complicated than that, but in general, that's one fundamental difference there. In the summer, it's not, they behave similarly. One thing to keep in mind is an HRV oftentimes does need a condensate drain, and ERVs don't. ERVs typically do come at a little bit higher cost. And for the purposes of this presentation and conversation, I'm going to primarily use ERV as the terminology, but it could mean HRV. It's not saying we are recommending ERVs. It's just, I'm going to use that term. This is a safe space. It's easy to interchange them. So that's how we're going to move forward. The types, as I mentioned, do have some trade-offs. One is plates can be sensible, or they can be, so a plate heat exchanger can be an HRV or an ERV, and wheels are more often than not an ERV. Plates don't have any moving parts. The wheels do. The wheel rotates. There's a motor and oftentimes a belt that turns the wheel. Plates commonly have the lowest cross leakage. So cross leakage is how much air could be transferred between the exhaust and the supply within the heat exchanger and within the ventilator itself. So that's a consideration for transmitting any pollutants in the exhaust air, and viruses is something we have to consider now. And generally speaking, plates have lower cross leakage and wheels will have higher, but they can be low. We'll talk about that a little bit more depending on the design and quality. Plates will typically be larger to have a higher heat recovery effectiveness. And you will see plates, heat exchangers in large units for centralized distribution, or the small unit ventilators are generally usually plates, and wheels are often only associated with more centralized equipment. I've not seen a wheel type used in a small single room ventilator yet. And then plates are, one consideration is the air, generally speaking, these heat exchangers, they have a certain efficiency in recovering energy, and unless you have some dampers to bypass the heat exchanger, or you change the speed of the wheel that it rotates, you get what you get in terms of the air temperature coming into space. So to be able to modulate that temperature, control it within the bounds that you can with just the heat exchanger and bypassing air alone, generally speaking, the wheels are pretty straightforward. You can just change the speed of the wheel to adjust the space temp or the supplier temperature, but the plates you actually need to bypass the air around the heat exchanger, which can make the ventilator larger and have dampers. So, a couple considerations on the types. We are going to focus. One of the specifications is to identify what a fan power allowance is for systems that were balanced ventilation systems, and that number is, in the context of our specification, it's described as watts per CFM. And that is simply, you take the power to run the supply fan, the power to run the exhaust fan, and any other auxiliaries of the unit, and divide it by the outdoor air delivered by that ventilator. And you can reduce this, the lower the number, the better. And it can be reduced by oversizing the ERV, using more efficient fan and motors, and duct sizing is really important in duct paths. So general goal is to get this as low as possible, but there's no way we can make it zero. And then heat recovery effectiveness. This is a common rating for all. So, if somebody says the ventilator is 70% effective, or 75% in this example, what that means is how much of the energy can be recovered and transferred from the exhaust air and carried over to the supplier. We're primarily focused on the sensible effectiveness, so how much we can change the temperature of the air, the dry bulb temperature of the air, and this example shows that at Seattle's design winter condition of 24 degrees and an indoor space temperature of 70 degrees, with a 75% effective heat exchanger, you will get 59-degree air supplied to the dwelling units under those conditions. So it just gives you an idea of, for those who aren't familiar with this, what effectiveness does. The higher the effectiveness is, the higher the supplier temperature could be. So you might see that 59 degrees go up to 62 or 63 if you have an 80% efficient heat exchanger, etc. Cross leakage. I mentioned this. This is a very, it's becoming more important to think about. As I mentioned, it's the percentage of air exchanged between the supply and exhaust air flows. It is part of most equipment certification programs, and the codes generally define it as has to be less than 10%. So 10% of the air on the exhaust could be actually leaked over to the supply air stream during the heat exchanger. And Passive House, for example, I believe has set this at less than 3%. As I mentioned, plates are generally lower than wheels. Balancing the pressure, so this is a design consideration, definitely helps in reducing cross leakage. And unitized systems, meaning unitized within just an ERV within just a dwelling unit by itself, that pretty much eliminates a lot of the concerns with cross leakage, because the crossover is within the air of the dwelling unit. Plate heat exchangers can have very low leakage. I mean, less than 1% or 1%. So it's it's not, I don't think any manufacturer would say it's ever going to be zero, but it can be very low, especially for plates. Filters is another area that we want to hit in our recommendations, and currently MERV 8 is the requirement on the supplier. MERV 13 in Seattle, I believe they're going to require for units greater than 500 CFM, MERV 13. For the kitchen exhaust, I actually could not find this in the code, but I believe that it's going to be good practice to put a washable filter and a grease filter on the kitchen exhaust grill if you are going to have local kitchen exhaust through the year. You don't want grease caking up your filters or your potentially your ductwork and heat exchanger. So what is generally accepted is that the particulate matter less than 2.5, any particulate matter less than 2.5 PM 2.5 micrometers is bad for you, and to get those pollutants out of the supplier, you generally have to go to higher filtration levels. MERV is a rating scale for filter efficiency, and only MERV 13 filters, if some of you may be familiar because they're becoming the de facto standard, those are actually, that's the first level where you actually have to have a certain amount of efficiency in removing particles less than 1 micrometer, and it has to be 50%. So it's good. It's not the best, but it's become, as I mentioned, de facto standard. And there are a lot of considerations with filters. Accessibility is probably one of the biggest because the cost of replacing them is part of the accessibility. And what I could gather was that MERV 13 filters on an annual basis is going to cost about twice as much as MERV 8. You know, we're not talking about necessarily thousands of dollars for centralized, or for some, depending on the design, I guess it could be, but there is a way using bag filters can help reduce that cost, is what we were able to find. And especially if we're talking about putting MERV 8 and MERV 13 filters in the unitized equipment within units, that comes at a higher cost per airflow rate. So that's another consideration. And this is I think informational in that what we know is that the smaller the in the context of box filters, which I think most people are familiar with, the thinner the filter, the higher the pressure drop, and the shorter time it takes for that filter to load or get dirty to the point where it needs to be replaced. So that's another consideration when choosing equipment is what size, how thick of a filter can it accommodate, or even can it accommodate a bag filter. So it's one consideration in the context of what we select for equipment. And this for me is kind of the elephant in the room right now on this topic. You know, we're learning, or we're very concerned about virus transmission, as we all know. There's been, you know, we talked about cross leakage as one of the ways that viruses could potentially be, especially if you have a centralized system, be, you know, transferred from somebody who is sick to somebody who was not sick. So, and, you know, this is an evolving subject, and I've pointed to 2 resources here. I'm really looking for more resources to kind of help inform the conversation. These 2 resources actually are somewhat opposite, or not completely on the same page. So it's something that we hope we can get more information here and talk about. So in the context of the we're going to get into layout options, and we're going to put this in the context of a prototypical building, a 4-story building, 72 units. And using the code calculated flow rates, this puts in context how much airflow we're talking about. It's not a lot on a unit basis, but then we get into some larger volumes as if you go to centralized systems. These are not that large, but bigger than just your exhaust fans. We've defined 4 principal options, 3 of them being centralized and 1 being unitized, which is the in-unit ERVs. This does not cover all of the different iterations and options and, that engineers have done or are interested in doing, but it's just to inform the conversation. And so particularly in informing the discussion on cost, how do we reduce the cost of the system, the construction costs and the maintenance of the system, because that's really what we're here to do today. And I think fundamentally each one is intended to eliminate one of the big goals is to eliminate dampers, fire and smoke dampers, because they add quite a bit of cost to the system. So that's one goal that we are striving for. The first one is the centralized, what we call the centralized layout for an entire building, or it could be multiple wings of a building. And that is generally locating equipment on the roof and ducting down to preferably having all ducts running within the conditioned volume of the building. And in this case, in a space below the roof. And then distributing out in soffits and down into the units of the building. Fire dampers are avoided in this case by only penetrating 3/4 assemblies. And if you want to have the ducts, the trunk duct within the ceiling of the corridor, in this case, within the conditioned volume, there is at least currently a need to request a code alternate in interpretation of where that trunk duct is with respect to it being the exterior of the building or not. We can talk about that further later, but it's generally speaking, this approach reduces the number of ERVs. It is a centralized approach. May require less softening depending on where those vertical drops are made within the units. But it does require more building height, and the first cost of the duct system is expected to be higher. And then once you go to more stories, more than 4 stories, you do have added costs because of this exception in the IBC only applies to penetrating 3-floor assembly. So dampers or shafts or other things are going to be required. And this system would have expected to be higher fan power. One thing about central systems that you'll see as a common theme is that tenants can't turn them off, or at least they can't turn off the airflow. They could cover grills and whatnot if they wanted to, but they can't turn off the fans. And whereas in-unit ERVs, you could, they would be able to. Just as an example, a recent Exemplary building pilot project did implement this strategy, DSC's Hobson Place South. And this is a schematic to try and illustrate the concept in plan view, at least. The ERVs in this case are located above the corridor on the roof and drop down to trunk ducts. And there's ducting out across on the top floor and down to the units below. The next layout that we've put together a diagram for is what we call stack by stack. This involves more ERVs, essentially one per stack of one apartment or two apartments, or as many apartments as possible to reduce the number of ERVs. But generally speaking, more ERVs and eliminating the trunk ducts in the corridor or potentially above the roof to distribute the air out. It doesn't have the building height impacts potentially as the first option, but you do get the same kind of distribution within the building effectively to the units. And another characteristic of central systems is you can't vary the airflow for an individual unit very easily without going to a lot of controls and cost. But so if you want to have, say, the airflow increased for a short period, as you might with an exhaust fan, you generally are going to affect, you can have that switch, but you're going to affect all of the units served by those ERVs. So a consideration, one of the trade-offs between these different options. Again, the fan power potential for this system should be a little bit lower than the first one, but still higher than in unit ERVs. Sorry. So this is an example of a project that was built I think 2 or 3 years ago now, and it's DSC's Estelle building. In this case, there's ERVs on the roof that duct out and then to a plenum and drop down in vertical home run ductwork to individual units on the floors below. In this case, and in most cases, the exhaust air is subducted into a common vertical shaft. That's one option for reducing the home run ductwork, but it's again, it's a vertical distribution to each unit. The third option is what we call floor by floor. So this is where you have ERVs either on every floor or potentially on the roof and ducting down to the individual ductwork on each floor. But effectively, the trunk ducts that have branches off to the dwelling units run on each floor, and this has the benefit of, again, not requiring increase in the height of the building potentially, depending on how big these ducts are. And also, you aren't limited by some of the issues that I mentioned for having more floors. You know, this system design is generally speaking the same potentially as for a 3-story building up to a high rise. So, it does take advantage of some exceptions in the building code for requiring dampers. So when you penetrate the corridor wall or passing over dwelling units, there are exceptions for not requiring dampers to be able to do that. And in this case, the variability in flow rate is on a floor by floor basis instead of a stack or a building basis. So there's a lot of variations of this one, especially. There's an ERV on each floor, but exhaust running your ducts up to the roof instead of horizontally out of the building, putting the ERV on the roof and shafting down to each floor, and then even, instead of running trunk ducts in the corridor, running them above the ceiling of units. So there's a lot of nuances to that, these strategies, but it can be done. There's some examples that Cascade built's Pax Futura project utilized more or less a floor by floor, so an ERV on each floor. It does kind of go up to some units above and below, depending on the location. But it's one example of a floor by floor distribution. The Solace project also used floor by floor. In this case, an ERV on each floor, and I believe ducting up to the roof for the exhaust and supply air intake. And 320 Queen Anne is, again, another 4x4 illustration, 2 ERVs per floor, primarily running ducts, trunk ducts in the corridor, and in one case, branching out across the units to serve units in the middle of the building. And last example for here is another cascade build project. In this case, the ERV located on each floor and running ducts in the corridor. And in this case, we bring the air in through the side of the building. So these are all just examples of the different centralized systems. And one lesson learned that we've Walsh recommended for the Hobson Place project was to, if you need more room in the corridor for ductwork, one strategy is to use car decking to span the corridor gap and freeing up a couple inches instead of using joists. That's just a real nice illustration of how to get more space in the corridor without adding building height. And then lastly, unitized systems are the installing a ventilator in each dwelling unit. This has a number of advantages in that you can vary the control for each unit. You don't have cross leakage at a central building equipment, or the potential for cross leakage can be designed for lower fan power, although it's not. That's not a foregone conclusion. And the trade-offs are, you have a lot more pieces of equipment to install and maintain, and the tenants could shut them off. You don't get ventilation for certain units, and as we talked about earlier, the separation of the exhaust and is difficult, challenging to locate on the facade, and adds penetrations, which can contribute to envelope air leakage and potential for envelope failure. So there's a number of trade-offs with the in-unit strategy, and this would be, I think, the discussion of recommending centralized versus unitized, or even if we should speak to that in the EB guidelines, is, I think, a really interesting conversation we're going to have. I can note that as far as penetrations, the state mechanical code does have an exception in the 2018 code for using these factory built combination hoods on the termination. But Eric Vandermeer had indicated that Seattle may not adopt this exception. So it's something that we should watch, but it is in the state code. This is a matrix that we've compiled to just try and summarize the comparison of the different categories we've talked about. In terms of cost, this is our initial gauge of each of these is that the more centralized you go, likely the higher the first cost, but replacement and operation, we believe, are generally going to be the lowest. And then, within the two centralized, which break up the building into smaller pieces, you kind of find that middle ground. And in unitized, we believe that the overall initial cost could be the lowest, although the equipment itself is probably the highest, but the replacement costs and the operation costs is expected to be the highest of all the options. These are generalized statements. Really interested to see if others agree, if we can have consensus on that. And all these other considerations we've talked about. I'm not going to go through each one here, but the goal of our effort here is to assemble this into a package of guidelines and background information that everybody can have. Here's another high-level comparison of centralized in unit.
So David?
Yes.
I just want to let you know there's been sort of back and forth about this in the chat where they were talking about unitized. And so I think Thomas said, we set ours up at SHA so the tenant cannot shut off. And then Sai was then asking, can you get the fire rating in 3-ply CLT?
Great. Yeah, I think we should try and talk about those comments when we break out or in the technical discussion.
Okay.
Great to hear that that's already being discussed. Yeah, so this is our assembling of information. It's not, it's certainly, we are looking for feedback and additional guidance and information from all the practitioners out there. We are trying to address commissioning in our guidelines as part of this effort, and it's extremely important to make sure that there's a design review for a number of considerations early on, but also field verification of many aspects of these systems. And then ultimately operations and maintenance, filter replacement being probably just the biggest one. There is these heat exchangers, these ventilators are pretty simple otherwise. They're just fans and a heat exchanger. And the wheels do add some extra components, and then this cleaning of the heat exchanger depends on the type, but that's another consideration that may need to be done periodically. So this gets us to just the recommendations that we're assembling. I've included in black font here the 3 that we've already identified that are already stated in our guidelines, and what I've shown here in green are some drafts for consideration that we've assembled. So I do look forward to, one, addressing filtration levels. I think it's fair to say that it's almost assumed that these are continuously operating. There are some considerations with whether or not we should recommend that these also serve corridors, especially for the central systems, or at least you add heat recovery to also serve the corridors, or with a separate system potentially to achieve the intent of the C406 credit in the code. I do feel that we should maybe speak to cross leakage in our specifications in the heat exchanger, and also just on the local kitchen exhaust strategies and what is the expectation, and even laundry dryers, in-unit dryers need ventilation. They need makeup air in some cases, or the laundry area does, and just how do you orient your units to incorporate in-unit laundry? So, and just this puts in context how is what we've defined in the exemplary building program compared to the current code. The heat exchanger efficiency or effectiveness is, we're recommending higher. The code is 60%. Generally, for a code compliance system, we're saying 75%. We're establishing a fan power criteria, which if you look at the code right now, unless you're going after a C406 option, or if you have very large ventilators, there's really no limit established in the code. And this is an extremely important criteria for achieving the effectiveness or the efficiencies that we hope to get with going to this technology. The C406 sections of the code do have established some limits, but we're somewhat in the middle ground between two of the options. And we are proposing that you adopt the distributed exhaust criteria. And as I mentioned, establishing if we, 3% is definitely lower than the 10% that would be required by code. And just to put it in context, the residential code, the Washington State Residential Energy Code, does establish for unitized in-unit ventilators a criteria of 0.83 watts per CFM, if I'm not mistaken. So this is all just put in context. Where is exemplary building compared to code, at least right now? So with that, I'm going to hand off to Joe to kind of take us forward.
Great. Thank you, David, for a detailed and highly considered presentation. What I'd like to do is take a couple of minutes for people to take a quick break, and we can reconvene. Let's say if it's now 10:06, try about a 2 to 3 minute break, and then we'll reconvene with our subject matter experts to take questions from the attendees, and as well to hear a few comments from each of the 3 subject matter experts who we've assembled today, and I'll introduce them a little bit further when we get started there. So 2 to 3 minutes and we'll reconvene. Well, welcome back, everyone. I have about 3 minutes since we last turned off the connection here, but what we plan to do going forward here is to introduce these 3 people who have had a lot of experience with doing design as engineers, and to have about a half an hour of questions and answers from the attendees, as well as a few comments from each of them to respond to the presentation that David put forth. Following that, we'll have a breakout into small groups of 5 or so people per each group to talk about their thoughts and concerns, and then get back together again after that. So we obviously don't have a lot of time. We can continue to use the chat to share questions and answers in the background. So to start things off, I'm going to introduce Galen Stengel, who I've worked with on a couple of different projects. He's more involved in the East Coast, but has done, I think, 3 or 4 projects here in the Northwest in terms of design on the market rate side. And Galen, if you want to say a couple words, if you have any immediate thoughts about what's been presented, then we'll move on.
Sure. I guess the first thing I'll say is that, I don't really think that there's a right way of doing things among the approach that's been presented. We use all of those different approaches in different projects that we work on. And, the COVID-19 context has really placed another layer on the thinking associated with the whole discussion about how many ERVs and whether they're distributed or centralized. The individual unit ERVs have the advantage that everybody's getting their own fresh air, assuming that we can take care of where the air is coming in and make sure there's no cross-contamination there. It's a really clean solution for making sure everybody that there's no potential for cross-contamination from your neighbor's ventilation air. Not that the risk is particularly high from centralized systems, but it is a little bit higher. So that's really provided another layer of thinking on the whole discussion.
Great, thank you, Galen. Second in our group of three here, I'd like to ask Eric Vandermeer from Rushing to say a couple of words. We've worked together on the DESC project, Bill Hobson Place Phase 2, and I'm sure you have a couple of thoughts to share before we jump into questions and answers. Eric.
Yes, thanks, Joe. So I guess I'll focus a little bit on the code side. I've been representing mechanical engineers on the Washington State Building Code Council since the 2012 code cycle. So I've been involved in the last 5 iterations of the mechanical code and energy code, I guess, for a state, something like that. So I have a lot of history as to how we ended up with the code we did. And, we're going to a new code process for the mechanical code with this balanced ventilation. I think it took us 2 or 3 cycles when we revamped the ventilation code for multifamily to kind of get everything right. So there are some definite questions and holes in it. And so we want to get some of those things cleared up today. But yeah, in general, look at each project and what are the opportunities and what are the challenges, and there's no one system that meets all. Outdoor air concern is one thing that hasn't been brought up specifically, but the MERV 13 push on filtration from the Seattle Mayor's office has been about outdoor air quality during the summers for forest fires. So that's another benefit to having ducted ventilation with filtered air going into the units. So yeah, there's lots of the COVID concern within the space and the outside air quality concern. Lots of pros and cons to talk about with the different systems.
Great, thank you, Eric. So moving on to John Heller from Ecotope. John, your company has been involved in probably more high performance ventilation systems than most in this area, and I'm sure you have a couple of thoughts to suggest in that area, and would love to have you jump in at this point.
Thanks, Joe. Yeah, we've, as Eric and Galen mentioned, we've tried all the different approaches to doing this. I would say that at this point, there is no clear winner. However, one of the goals of the Exemplary Building Pilot and this program by the HDC is to try to figure out how do we drive the costs down for these high performance approaches. And I believe that to really drive the cost for heat recovery ventilation down, we need to be thinking about moving towards more of a standardized approach. Something that the industry can get behind and understand and just do it the same way, rather than every single building being a custom engineered solution every time. So I don't know if that's possible, but I think that that we should consider trying to figure that out. If there's a way to make a one system pretty much the standard solution, it would go a long ways towards driving the cost and complexity of these systems down.
Great, thank you, John. What I thought we might do here as we move into questions and answers is Lauren, I'm going to ask you to moderate this if you can. I suggest that maybe people can put their question on a chat, and then maybe Lauren, you could select people to turn their mics on and ask their question accordingly. Does that make sense, Lauren?
Sure.
So we've suggested a few questions, but obviously there's questions that people have individually. So please go ahead and step forward and advance any questions you might have for our subject matter experts and for David.
So Charlie did have a question that Galen kind of addressed, but I'll read it to see if anyone has any additional thoughts. He's wondering if the scope of this is just for new construction. Should we have a different recommendation for rehabs, and do we expect DOAs to be required for substantial alterations of existing buildings?
So who would like to jump in on that?
Eric, are we going to require balanced flow for rehab in the code?
Well, I mean, general remodeling an existing building under the state code, at least, you wouldn't be required to upgrade the ventilation system. You're allowed to replace components within the existing building. You know, from an energy code standpoint, you know, the Seattle Energy Code does have the substantial alterations section of the code, which requires you to bring, you know, when you meet that substantial alteration definition for the building code, then you do have to bring the building into full energy code compliance. So that's where you get into that discussion and negotiation with the city. But there's no like retroactive requirements or, you know, requirements that would trigger, I guess, replacement of an entire ventilation system for the building at this point. So, but I know
very challenging.
Yeah.
In most existing buildings to get balanced flow ventilation in, because of the requirements for separation from operable windows. All of the facade is hard to adjust. It's hard to get a central system in without a pretty significant gut of the interior. I'd also point out that existing buildings are going to be a lot leakier than the buildings that we're building. So the kind of the need for heat recovery ventilation in existing buildings is going to be lower, or the advantages to it, I guess, because if the building is already leaky, you're not going to get the energy advantages of heat recovery ventilation.
Great, thank you. Thank you both. I see another question coming up from Thomas. Would you like to speak your thoughts, Thomas? So what Tom wrote is, it seems like a standard solution would have to be unitized because buildings vary so much by size, stories. So the question is, how do you standardize a centralized approach? So maybe someone could address standardization in the context of a central system.
I like the floor by floor, zone by zone approach. I can't argue that I've got a standardized design approach to that yet, but I think there's a lot of advantages to it. And where you would go as far as standardizing it would be to try to standardize it to a low profile unit that could be installed in a mechanical mezzanine over the corridor, and distributed horizontally without the need for shafts and fire smoke dampers. That's kind of my thoughts about how you might standardize on a semi-distributed or semi-centralized approach. But I mean, I think you're right. I think a unit by unit approach is easier to standardize. Just there's the drawbacks of that are David pointed out, there's acoustics, there's maintenance, there's the coordination of the facade and all of your, it's very difficult to coordinate that, the facade and balanced flow heat recovery ventilation on particularly small apartments on a double loaded corridor situation where you may only have 12 feet of exterior wall.
So Galen, I wonder if you have any thoughts on this question of standardization.
Yeah, so I mean, I think we find that these the three different approaches, sort of central, semi-central, and distributed, really depend a lot on the building configuration and how many windows, how much window area you have on the facade, and also the structural system that you're using in the building. So, to the extent that you're standardizing all of that, then maybe it makes sense to standardize your ventilation approach with it. But I don't personally see being able to say, we can come up with a perfect ventilation system approach that's going to apply to all multifamily construction going on out there right now. It seems to me that it's really, there's a lot of factors that are integral to the building design that need to be considered. And those factors, I think this question really needs to be considered early in design with the whole team, because the structural system and the floor-to-floor height and the facade all are impacted by this discussion. So it's really a key conversation that needs to happen in schematic design.
Great, thanks, Galen.
And Joe, before we move on to Alan and Lori,
Yeah.
I think Tom had some additional input that he wanted to add to his question.
Sure, go ahead, Tom.
Tom, you
not
may
here.
still be muted.
I was going to say, just to respond to Galen, there's kind of three main structural types for multifamily that maybe we should be talking about. There's the low-rise woody walk-up type. There's the mid-rise mixed-use 5/2 type, and then there's high-rise. And I think that just developing in my mind, maybe there's a different standardized approach, or as standardized as it can be for those three. And maybe it ends up being the individual units in the low rise, floor by floor, zone by zone in the mid rise, and centralized rooftop in the high rise, for example.
Great, thank you. Thank you, Jonathan.
And then you can this is Eric, you can kind of overlay your different building types being, apartments, student housing, senior housing. Some of those have some special conditions that may, so you may end up with, multiple, kind of a complicated matrix of a standard approach between height of project and use of project. So
we have a couple other questions here from the attendees. Alan asked, how does a heat recovery system work in summer when outdoor temperature is greater than indoor? I guess that could be a quick, short answer from someone.
You get a little bit of cooling benefit, very little.
But it's not a loss, it's a benefit.
Yeah.
Then there's a question from Lori on MERV 8 versus MERV 13 in terms of the upgrade for the unitized plate systems. Is it as simple as making a switch of filters, or does the filter thickness come into play as well?
Yeah, the filter thickness does come into play, because when you increase to a higher efficiency filter, then it will plug up faster and it will have more pressure loss if you don't increase the depth as well. So we typically ask for increased depth when we ask for MERV 13 filters. So we go from a 1 to a 2-inch filter there, or something like that.
So we should start off with our equipment allowing for that.
Yeah, unfortunately, the smaller unitized equipment don't typically accommodate. It's usually either a custom filter or at least a 1-inch filter. So that's more challenging for unitized. I did see a question earlier about what's a bag filter. I brought up an example on a screen here. Hopefully you can see it. It's literally a bag of filter material. The trade-off is that it's a much deeper filter assembly, so it makes the air handler, and it's basically, it's not an option for unitized equipment. So hopefully that helps.
There was a question from Bill Singer about permanent supportive housing projects and whether cross-contamination and hygiene concerns are higher than other projects. And my guess is the answer is it may be true. Has anybody had to deal with that?
Yeah, actually with environmental works way back, we had a building with a central heat recovery ventilator and somebody cooked meth in one of the units. And the concern about cross-contamination was pretty huge in that building. I don't know if Bill, if you were around at that time, that was the up in Bellingham, the Katera Court, I think, or Kateri Court project.
Yeah, I know it. Michelle from CCS, who's also on the line, I don't know if she knows about that one, but there was significant damage. Yeah, they had to tear out ducts, and it ended up the repair work was quite a lot, and so we were informed after that not to do centralized exhaust systems anymore. I think in particular that used a shared shaft rather than direct ducting to the units, which is what we did at Claire's place. So,
you know, actually, I think that the heat recovery ventilator was collateral damage there. I don't believe that it contributed because we were only exhausting the units.
Okay.
There was no supply to the units from the heat recovery ventilator. We were exhausting the units and then supplying tempered air to the corridors. But it was perceived as the route for contamination.
So we have another question here from Charlie Rogers clarifying the ventilation CFM requirement being the combination of supplying exhaust and not an additive. Correct, David?
It's not the average. Well, it's generally speaking, it's the amount of supply outdoor air provided.
Well, it's the larger of the two. If you're driven by exhaust, you have to provide enough makeup air to get within the balanced requirement, which I forget what exactly that is, 5% or 5 CFM or whichever's higher there, 10%, I think. So if you have an apartment that requires 20 CFM of bathroom exhaust and 30 CFM of kitchen exhaust, then you have to supply almost that much fresh air in order to keep it balanced.
Right. So it's not a sum of the two. It's the supply, the exhaust requirement. Is what you're saying?
It's the larger of the two.
Yeah, okay.
Yeah, unless you put intermittent exhaust in the kitchen, for example. So you could be, like David mentioned, you could have a kitchen exhaust flow rate that keeps you distributed, but that's lower than the code. And then you have intermittent exhaust in the kitchen also, with the range hood, for example, that allows you to call that to meet the local exhaust rate via the intermittence. You have to take a look at your whole house rates and your local exhaust rates and figure out how you're going to set up the system.
So there was a question here from Tom about who on this meeting invite are members of the State Building Code Council, and you can maybe put your names into the chat room if you're willing to, while we move on to getting ready for the next phase.
We have, Joe, we have one more quick question from Phoebe, who is wondering Should we be requiring a bypass to save energy during mild and hot weather?
Good question.
I have my opinion. I'd like to hear from the other guys. I don't think it's worth it personally in the Seattle climate. I think it complicates the equipment too much and adds too much cost and complexity to the system. But I'd like to hear from Eric and Galen what they think.
I guess I would say not on a unit by unit basis, but as you move more central, you know, with the systems and whether the spaces have, you know, mechanical cooling or not, that could influence your, you know, your decision to put a bypass in the central unit. And then, you know, the 2018 Washington State Energy Code does clarify that if you have mechanical cooling in your central rooftop unit, for example, in your central ERV, because you want to do some supplemental cooling in that, then you would now need to have the heat recovery bypass dampers in that unit. So yeah, there's definitely some different considerations to make. That was one of the discussions, like on DESC, was overheating the building during the summer, and, you know, do we want to put, you know, cooling in the central ERV because there is no cooling in the individual dwelling units throughout the building. So it's definitely something to look at if you're going more central and you're making your DOAS units more complicated. So,
Galen, any thoughts there?
I wouldn't require it. I think it's a, you know, marginal but significant energy savings in this climate. But the problem is that, and this is a problem for a number of factors, you know, as we change scale from ERVs, our available product is really inconsistent. And so, you know, at certain scales, it's just not realistic to get bypass. Whereas if, you know, if you're central, it's easy to do. So I don't think we have the equipment to justify making it a requirement.
Great, thanks. And Ryan, you know, go ahead. Someone else want to add?
Joe, I just wanted to address a question that Tom Eanes, I think, posted regarding the occupant control of the unitized in-unit equipment.
Sure.
I think I stated that you needed to provide a switch to turn it off, but is that a code requirement or is that just a nice to have?
yeah, that is a code requirement that the unit by unit systems have to have the fan on switch. And again, that's an ASHRAE 62.2 recommendation. It's based on outdoor air quality, and that people should have the ability to turn off their ventilation system based on, you know, bad outdoor air quality. So that is the recommendation of 62.2. The central systems, we do have an exception in the code that says you don't have to provide on central systems that ability to have unit by unit control of the ventilation system. And part of that's because we typically have better filtration at the central systems. Again, the code minimum in the Washington State Code is a MERV 8 filtration. Seattle is going to that MERV 13 with an exception for small systems. Likely that's probably going to be set at 500 CFM. So yeah, that's kind of the code basis versus, yeah, I think that answered your question, David.
Yeah, thanks. And then maybe before we hit breakout sessions, if there was any of the criteria that we've already have or have proposed adding to the exemplary building recommendations that you take issue with or want to reinforce, change.
I got one more question from Ryan Mino, whether STC ratings are a factor in deciding which systems to use.
I think acoustics are a really, really important part of this. When you put unitized approach, you put the fans in the apartment units and there's this constant noise that you're going to have to deal with. On the other hand, using a centralized or semi-centralized approach, you've got the potential for crosstalk between apartments with noise traveling down the ducts, which can be an even worse acoustic problem. I'm wondering, Galen or Eric, have you had experience in projects where crosstalk has become a problem?
Well, we've talked about it on projects. You know, one of the challenges, obviously, in 4x4 or a central location is how do you run both those ducts down the corridor? So we have looked at projects where, you know, the exhaust duct is going down the corridor and the supply duct is penetrating the demising walls between units, and that gets really challenging with, you know, there are exceptions that allow you to, for certain duct sizes, to omit the fire dampers at the demising walls. But that does present a challenge for acoustics between the units for sure. So I think it's more of a challenge on the supply side than on the exhaust outlets from the bathroom. So,
What's your experience, Galen?
Yeah, it's definitely a challenge with the semi-centralized and centralized approach. And, you know, we're taking a lot of steps to try and reduce the crosstalk, but it's definitely a challenge.
So it needs to be addressed.
Yep.
And then the code has, you know, zone ratings for the fans and such that are still required. So.
And then Sean Orem asked the question, can we discuss challenges with balancing such low flows on central systems and any recommendations for good success?
Well, I can offer some experience based on commissioning the Estelle project that was mentioned. That was used car dampers for all of the supply and exhaust terminations. And what we, in a sampling of airflow rates, they all looked good. But then when we went to 100% testing, we did find, I can't remember the exact percentage, but a fair number that were not within the design range. So that definitely has reinforced in my mind the idea of 100% testing, even if you are using cars, constant air regulators. And it's really important to look at the selection of those car dampers because the pressure differentials across them really make a difference on whether they work. And so if you're not paying attention, they may not be actuating as you expect. So that's just some guide. And then we are also involved in a centralized system that did manual balancing dampers. And yeah, it's a real challenge to get them within, get them all dialed in together at the same time. So, but
so Sean, do you want to jump in and add a few comments?
I guess I'll add this, Eric, again, that it's clear now in the code that these systems have to be completely balanced. So the code was updated at the state level to require that balancing activity. So there's much cleaner language there that's enforceable in regard to balancing. And then, yeah, paying attention to your constant airflow regulators if you're going to use them. Each manufacturer has different pressure ranges, and you might, need different regulators on different floors for central systems. There's different quality of regulators out there. So yeah, that's definitely something to pay attention to and have good access to balance dampers and stuff if you're going to go manual. So.
Galen, how have you addressed that in your central system designs?
So we avoid the constant air regulators because of the increased pressure drop associated with them. We've in general either used semi-centralized ERVs or put fans on each floor in order to avoid pressure differences associated with wind and stack effect. And then we use either iris dampers or the adjustable Seho grills that allow you finer control. And with those approaches, we've had good success. I won't say that it's not a challenge to balance the systems, but we've been able to get them in balance, and we feel like they're staying reasonably in balance over time.
Thank you, everyone. What I'd like to do is transition now to our breakout groups. I think, Lauren, you organized everyone into breakout groups with certain of the leaders in each of the groups. So this seems like a good time. And what's going to happen, I believe, Lauren, is everyone will automatically be shifted into a small group where you can have conversations about the topics we've discussed or specific things that we've listed you might want to review in your small group. We'll designate about a half an hour for that. And then we'll try and come back and have one person from each of those small groups report what they would like to say to the group at large. So Lauren, you want to guide us through that process?
I will. So something that I wanted to address before I send you off into your groups is the breakout rooms are kind of wonky because if you're calling in on your phone and you also have your screen up, you could be put into two different groups, which is kind of awkward. So I'm going to read out 3 phone numbers, and I'm hoping that if those are your phone numbers, you can let me know, and I'll try to make sure that the numbers are in the same group as your screen. So I have a phone number ending in 4798. Does that belong to anyone? All right, hearing nothing, I have a phone number ending in 3915.
Seems that maybe
Right.
everybody is muted except for the speakers. We haven't heard from anybody else.
It's not a big deal. If you have your screen up, you'll be in a different room than your audio. So I would just say, pay attention to the audio that you have. Last question I have is 8245. All right. Well, we'll just go with the flow here. There's a couple people that joined a little bit late. So Joel and Marty, you'll receive an invite momentarily, but everyone else should be receiving an invite in just a second to join your rooms.
Okay, sorry to cut everyone off so quickly there. I guess you probably saw the notice that we were going to shift back to the main room. Lauren, do you want to say a few words?
No.
Okay, great. What I'd like to do
like me to
is,
say a few words?
what I'd like to do is ask one person from each group to maybe report back on the key topics that were discussed in their group. So this is a volunteer system. We did not set up these individuals in advance to represent their group, but please step forward and say what you think are the key 3 or 4 subject matters that you thought should be brought to the table for everyone's attention.
Well, Joe, do you want to start?
I'd be glad to start, sure. So in our group, we had 2 things that were of major concern. One is concern about overheating in summer and how to deal with it, and whether or not having a tighter building envelope and heat recovery ventilation was helping that or hurting that. And I think there are some different thoughts about it, but it seems as though if you do a good job with your windows and you're reducing leakage into the space, that you're actually helping the situation a little bit, but we probably will need more help than that. And one thought was to add cooling to the return side, to the supply side of the ventilation system on a central basis that will help mitigate the heat. So that's sort of where we landed on that one. Another kind of radical thought that Sean proposed was looking at swing seasons of spring and fall, where you could actually turn off the central system and just open your windows. So we'll sort of leave that one out there as a wild eco idea, but something that we may consider in the future. So that was our group.
Yeah, actually, to kind of talk about that idea for Estelle, actually, the ERVs have independent fans on the supply and exhaust side. And so we did play with just shutting off the supply fan in the summer, assuming the windows were open and it would act like an exhaust-based ventilation system in the summer. But certainly with a control system, you could even optimize that to turn it on at certain times or do that, you know, to potentially optimize use of independent fans or shutting it off during certain times. So I think with centralized systems, you have that flexibility.
So can we get another volunteer from another group to suggest a few topics of concern?
This is Eric from Rushing. Our group talked about costs, both cost of first cost and maintenance costs of the system. Talked a little bit about differences in costs and maintenance for unit by unit or centralized systems. We also one of the things that we talked a little bit about is that the 2018 mechanical code doesn't require the laundry room to have an exhaust fan anymore, so you don't have to pick up you know, local exhaust out of your laundry room. And we talked a little bit about how heat pump dryers work and how as the building envelopes get tighter and tighter, that it's harder and harder to get makeup air for both range exhaust and or, you know, electric ducted dryer exhaust out of the building. So so that was kind of a point of discussion, that operable windows need to be open to run things like a larger range hood or a closed dryer to get efficient operation if it's ducted. Whereas if you go to the heat pump dryer or the recirculating range hood, then you don't have to bring in that air through an operable window or through another opening in the facade to deal with that with a really tight building envelope. So those were a couple of things that we talked about. And so I don't know, one of the questions that came up that I couldn't answer well was, are there any good studies out there of the costs of the different types of systems, you know, holistically, not just the mechanical system, but electrical and, you know, architectural and structural impacts? And is there any good studies of maintenance costs, you know, distributed versus centralized? So if anybody has resources on that, those would be helpful to share with the team.
Those are certainly things we hope to learn in this demonstration program as we report back on costs. And I think just to bring it to people's attention, the better we can do on evaluating those costs as we progress from the various trades, you know, the various pieces and parts that feed in, if that could be built into the program, that would be ideal. Another group we want to get a report back from, who wants to volunteer?
I'll go. So we talked a little bit about COVID-19 and real and perceived risks. We talked about the fact that, you know, the distributed ERVs, you know, take care of themselves in that, you know, each apartment has their own fresh air. And that the centralized ERVs, if we talk about adding UV or plasma for reduction of virus particles. It's not particularly expensive, but it's pretty inexpensive when you talk about a central system because you're only adding one for each ERV. We also talked about standardization a little bit more. There was a suggestion that in rehabs, individual distributed ERVs is, probably the most practical approach in most situations, and so that might be a good standard for rehabs. There was in new construction, there was a bias towards centralized, I think, for the maintenance associated with it. And then we also talked briefly about some of these unitized products like the Luno system and the Panasonic ERV that handles exhaust and supply in one place. It was agreed that those products are have their own sort of difficulties associated with them and have to be used carefully in order to comply with code and in multifamily.
Great, thanks, Galen. Lots of good topics there to consider as we go forward. So that takes care of, I think, 3 groups so far. We probably have a couple of more groups to speak up.
I can go for my group. It's Michelle Mott, High Catholic Housing Services. So for my group, a big reason why I'm even a part of this discussion is because I was a developer for Claire's Place, in which we are a UHE project net zero, and we completed up in Everett this past summer, July 2019. One of the big things that we faced was that we actually didn't get our TAB report approved by our mechanical engineer until just a month ago, I want to say. And we had a lot of issues in testing and balancing the building. Part of that is that our HRV units weren't meeting, so they were designed, so for I believe the unit fans were designed at 50 CFM, and I see Bill Singer and David Reddy on here, so I'm gonna kind of punt if there's any questions that go to this afterwards. But basically, given that we were building a PSH building, the units were designed with a higher CFM than what the minimum requirements would be. And that was because of the hygiene, question and thinking maybe this would be better airflow in the units. And they were also designed with a tolerance band of plus or minus 10% CFM. And a number of the fans we found met the code, but weren't able to meet the tolerance. And so kind of came into question whether or not, one, our design that we had set for ourselves was too high in and of itself, and then 2, maybe the tolerance band was too slim. Because we had some units that were at 30 CFM. And so that was a lot of back and forth in what we've had to kind of discuss, and we're trying to figure out at our building. Other factors in that also, just for the developers and contractors in the room, would be, we are trying to test and balance our building while we had residents moved in at the end of it. And I think, trying to getting our testing and balancing completed 100% before residents move in is key. Of course, developers face challenges on timing and, trying to get people in. So just making sure that you have your commissioner, your third-party commissioning agent, as well as your TAB, what's called vendor, able to be involved earlier in the scope, understanding the full scope of the complexity of the system, so that once it's time to actually get these systems commissioned and balanced, that everyone's involved in understanding it earlier. I think those are just the key lessons that we've learned on Claire's Place. I don't know if Bill or David have anything else to add, not being in my group, but just being involved in that project specifically.
Open to some additional comments from David or Bill.
Yeah, no, I think this is a big change, and everybody needs to understand the impacts on in this case, it was construction timing and testing and commissioning. I think it was really underestimated how much more time it was going to take to balance and get the system dialed in. So we need to build that in.
Great. Thank you, Michelle, for bringing those questions up. I think that's a really key piece of the whole picture. The commissioning at the time of occupancy before people are moved in really gives us a lot of chance to optimize the system and to learn from what's actually been designed and installed as well. And feedback at that point to the rest of the community would be ideal. So I think we have one more group that hasn't had a chance to speak up yet. So looking for, I think, the fifth group.
That was the group that I was involved in. I can report out for us. It was myself, Marty, John, Michelle, Lori, Brad, and Marcus. And we talked about a couple of different topics. We talked about the strategy, the kind of overall strategy, centralized versus unitized. Lori shared her experience with unitized as being kind of SHA's current approach. But that, you know, with some of the information we talked about today, centralized and some of the benefits, it may be reconsidered. We talked a little bit about cost. So the presentation didn't focus on cost as much as I think our effort is intended to. And so that's really something we talked a little bit about. We talked about maintenance costs and softening costs and some of the fire rating requirements of different building types, the 6 versus the 5, and how those can all factor into the decision of the right system. I think we all agreed that a hybrid of some general guidelines of not saying it's always 4x4 for every building, but perhaps it's decision matrix. Say if you're over four stories or over 4 stories, you split it up into this, maybe a central vertical system for the top 4 floors and 4x4 for the lower ones, or unitized for larger units. So those kinds of ideas may be something we want to consider in our recommendations.
It sounds like we have some work going forward for sure in
Yeah.
terms of making recommendations. So I think we've had, I think, some comments from every group, and I think we have a little more time where if there's, you know, maybe 10 minutes here, people can pipe in who may want to add a few questions or thoughts from the group at large before we wrap up. So sort of opening the floor to folks who may want to say a few words.
Joe, hi, Steve Gelb here. So I caught just the tail end of the group. I was in another meeting, but I think when you look at costs, to as specific as we can get, and to consider life cycle cost analysis, so that, you know, it's really hard to weigh maintenance and replacement costs with upfront costs unless you make it apples to apples. So I think being really specific there, and that might help decision makers point them in the best direction. And in some projects, first cost is going to be primary, but at least having that information, I think, can be really helpful. You know, part of our objective of the exemplary building is to make any premium costs on the building financeable. And to do that, you need to know what those long-term costs are and what the net present value is. So I just leave it at that.
I think in that analysis, also taking advantage of the benefits that might accrue in terms of health and comfort that are often not taken into account.
Yeah, I had a question I wanted to pose for, not being in a group with any of the contractors that are attending, I was interested to hear any of the contractors speak to the costs of the different strategies we've talked about. The first cost that, I don't know, I don't know if we have any mechanical contractors on in the workshop anymore, but at least the GCs, they've looked at this.
David, this is Ryan. I think an overriding theme that we talked both here and in our breakout session was just how early in the design process we can make this selection. I think that's a big factor in the cost of this initial upfront cost of the system.
Great, yeah, makes sense.
Yeah, my response to that, Ryan, is that's where it takes the best available knowledge and experience to bring to bear. And hopefully we can, through our Exemplary Buildings program, contribute to that conversation by bringing some expertise from wherever it occurs to help early integrative design to arrive at a good solution.
Michelle has her hand raised.
Thanks, Lauren. I wanted to ask, in regards to using a unitized system, if there are any, if anyone has any experiences that they can speak of with the residents actually keeping them on, if there's any issues in regards to maintenance for that type of a system, and things like that. I think from an operator standpoint, we've been concerned about going towards a unitized system in that residents might not keep them on, and then you have issues with mold and whatnot in your bathrooms later down the road. So wondering if anyone can speak to that.
I think, Tom, you had some comments earlier about that, if you're still here. I think the comment that he had written was that they found out when there was access to a shutoff switch, they found that oftentimes all the systems were turned off.
That's been my experience as well.
Interesting code problem.
Yeah, I wouldn't mind adding something too. Is that, you know, part of that issue is education piece for the residents and a good orientation, and also that being inspected with all of the inspections that happen within the unit, especially for, you know, our purposes at SHA. So we continue to inform the residents of the benefits of keeping that on, and just striving to educate them on that topic.
Do you know why they would have been turning them off, Lori?
I think they just feel like that the energy is being sucked out of their unit. So they think that they're paying for heat that might be leaving the unit, and not understanding how the system functions, you know, kind of creates that concern, and they look at it as money out the window.
I think that education is a very key component. I've actually been in a large senior housing facility where there was a sign posted in the elevator that said, "Residents, please note, it's wintertime, close your trickle vents." I thought, oops, that was the wrong information to be sharing. Well, the table is still open here for, the floor is still open for additional thoughts, comments before we go into a wrap-up mode.
I wanted to share maybe one perspective from California that involved in developing the compliance analysis software in California. And the California Energy Commission has recognized, they actually are considering implementing in the analysis a derating of the effectiveness of in-unit heat recovery systems for multifamily, recognizing that A, they are being turned off, and B, they are not, say, they're not achieving the energy savings that you might think you're getting when you look at a spec sheet. So it kind of just points to the idea of that there is recognition that these in-unit systems aren't always working or running as they should be. Is all to say. So,
good point.
At a state kind of code regulatory level.
So
And I'd like,
go ahead.
Let me just say one more thing. So when we've seen centralized systems, you know, what we see then in that case, if there's no shut off, is that they'll just cover up the exhaust vent with a piece of paper. They'll tape it up there. So it's not foolproof. So just wanted to add that.
Yeah, and we've seen that in DSC projects, more potentially on the older exhaust. They would tape over the exhaust, but that's definitely a good point. One consideration that Dan Whitmore, who wasn't able to join us, has shared, I guess through some passive house projects that he, and maybe Galen, you're aware of this, but there has been, because of the air, the temperature of the air and where it comes out in the dwelling unit, it being cool, it's inherently going to be cool in the middle of the winter. But that there's this kind of fine line of what's acceptable to the point where the tenant would just have a tendency to tape it off, like you're saying, Lori. And that speaks to potential, you know, the efficiency of the heat recovery unit. The higher the efficiency, the warmer that air will be in the winter, or potentially adding a heater to the central system, or locating where that air comes out in the unit in a place such that it doesn't, you know, the tenant doesn't experience that cool air. They don't notice it. So.
Any thoughts, Galen, on that?
Yeah, that's a really good point, and something we didn't really talk about very much, but in the spirit of lessons learned, you know, we have put outside air supply grills in poor locations and had very negative results. And so we're very careful about thinking about where that airstream is going to go and how it's going to mix with the room air prior to you know, the occupant's perception of draft or that kind of thing. So high sidewall grills that aren't pointed, you know, directly at the bed, you know, using the ceiling to help move the air across the ceiling and mix with the room air before it comes into the space. Those are very important considerations. You can't just dump the air into the apartment and feel like, you know, that's going to necessarily work out well.
Any other thoughts on that from our subject matter experts? Good point. Good question. It's something to be concerned about and address as we experience the actual operation of these systems. Well, my thought here is, David, do we have anything else you want to add to this conversation before? I was thinking we might ask each of the subject matter experts to say a few words in closing here, and then maybe turn it over to Marty to do a whole program wrap up. Any thoughts, David?
Well, I would love to hear feedback here, or send us an email with any questions or concerns on what we presented. But more importantly, like these specific, ultimately, we do hope to kind of distill this down into a handful of bullet points of requirements or guidelines that teams can take to incorporate in the beginning of their process of design. They can put them out there, and rather than exploring every single option under the sun, that they start with maybe a couple of principles. So I'd love to hear that feedback, and get that. And then the other thing was controls. As buildings inherently to meet our goals, I believe that there will be more emphasis on controls, and then this question of, you know, incorporating cooling into our units. How does that change the guidelines in any way? That's an ongoing discussion topic that I hope we can all get in on.
So please, by all means, folks, send your questions along to David, myself, or I think to Lauren, who could distribute those questions back to the team. Well, with that, let me ask John Heller, are you still with us, that you could offer a few thoughts here as we wrap up?
I think John had to leave early.
Okay, John had to leave early. Great, thanks. Eric, would you like to have a few wrap-up thoughts here at the end of our session?
Well, I'll just remind everybody that the codes are still in process for Seattle. And so if we do get things that need to be fixed in the code, we can work with SDCI to try to get that fixed maybe. The State Building Code Council, you know, would like to get feedback on, as you read the code and you're confused, so that we can at least make the code better for next time. But yeah, this is a big challenge, as we know, for the state, and education is very important to making this a successful venture for the state. And so just really appreciate the process that's here and the opportunity to be involved in it. So.
And thanks for joining us, Eric. Galen, do you have any wrap-up thoughts you want to share, or words of advice to the team, to the group as a whole?
I just think this is a really great process. Echo what Eric said. Talking about this stuff up front before folks get mired into a project can really help people go into it with their eyes open. So glad to be a part of it.
Great. So Marty, I'm wondering if you'd be willing to take over here and just give us an overall perspective from the head of HDC and going forward.
We lose Marty.
Maybe Marty's away.
Well, this is David. I just wanted to reiterate my thanks to the subject matter experts, Galen, Eric, and John, for their contributions. Really to get your input on the content. And I thank everybody in advance for their follow-up comments and help in drafting these guidelines and specs that we're working on.
And everyone should have received a copy of the key slides that David sent out previously. And if for some reason you did not get it, I believe it's going to be posted to the Exemplary Buildings Task Force website. So Laura, maybe you could verify if that has happened or will be happening.
Yeah, we can post it to the site, and I'm happy to send it to you directly if you shoot me an email.
Great. Well, this is awesome. A big step. So thank you everyone very much for contributing. I see there's in the chat room, Lauren had put down her email address there. If you need any information or questions, please contact her, and then she can reach out to us who have been working with the task force to go from there. So thanks everyone for participating. It was great.
Thank you.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you so much.
Thanks, everyone. Bye.